All right, next in the unit we're going to be graphing polar equations. And when we graph these, sometimes it helps to convert it to rectangular. Sometimes I think you could probably honestly just graph it the way that it is. So for the first example, you can do this on the line paper and on the graph paper, or you could just do it on the graph paper. It's up to you. But the first example is r equals 3. And if you want to rewrite this as a circle and then graph it like it's a rectangular equation, that's totally fine. It would be x squared plus y squared equals 9. So you're just remembering that this is, r equals 3 means we're talking about a radius of 3, so the shape we're talking about would be a circle. This is an equation that I honestly think is easy enough to graph in polar. So in polar coordinates, you just say, okay, I want the circle in here that has a radius of 3, so I'd go out 3 and then I'd follow the circle shape. If you were going to graph this exact same equation but think of it as rectangular, when we graph from rectangular form, we usually would plot the center first, that'd be like 0, 0, and then from there we'd go like up 3, right 3, down 3, left 3, and then we would connect our points. And you can see that either way it's the same graph. So for me, this is an equation where probably it doesn't really matter if you convert it to rectangular or not to graph it. But if they ask you in the directions to convert it to rectangular, that's what you would do. So anytime they give you a plain old radius, they're talking about a circle. Okay, next, let's say they gave you the equation theta equals pi fourths. I'm sure you could actually picture how to graph this. You would just look at where pi fourths is and then draw that line. That's what it is. So, but we're going to convert this to rectangular first. So before we convert it, it would be helpful to remember that tan theta is the same thing as y divided by x. That was like a substitution that we looked at, or how to solve for theta before when we were converting forms. And so we're going to do that exact same thing now, but we're just going to take pi fourths and plug it in for theta. So I'm going to say tan of pi fourths equals y divided by x. And if I look at tan of pi fourths, that's just plain old 1. 1 equals y over x. And in rectangular form, equations are usually solved for just y. So I'm going to multiply by x on both sides, and I get x equals y for the equation y equals x. So that would be like the rectangular form of the original polar equation theta equals pi fourths. All right, now if I was to graph this using the polar coordinates, I know that pi fourths is over here. So if I want to graph that equation theta equals pi fourths, then that would be this diagonal line right here. If I was to graph this from rectangular form, the equation y equals x, the y-intercept would be 0. So I'd be like, okay, here's my y-intercept. And then from there, I would go up 1 over 1, up 1 over 1, up 1 over 1. Sorry. And so you can see that the equation is the same line. It's the same graph. And honestly, graphing from either one of those, I feel, is equally pretty easy. If you're going to be graphing these in rectangular, you almost think about like this is 1, 2, 3, 4, 5. So even though the grid isn't drawn for you, you can still go like over and up and that sort of thing. Okay, here's another example. These are the ones where it actually helps to convert it first. So let's say we have r sine theta equals 2. R sine theta is just another way of saying y, so this would be like y equals 2. And if you guys remember, in rectangular form, y equals 2 is just a horizontal line that goes up 2. So on this one, you're just going to go up 2, so there's up 1, 2, and then you're going to draw a horizontal line. So you're drawing it on a coordinate graph, or on a polar graph, but it's kind of like you're drawing a rectangular equation on there. We might also have equations like r cos theta equals -3, and then we just have to remember that r cos theta is kind of like an x. This is like x equals -3, and so in rectangular form, that's just a vertical line. So we're just going to go to -3, which is right there, and draw a vertical line. And the only difference is we're drawing it on a polar graph instead of a rectangular graph. All right. Now sometimes the equations get a little bit more complicated. So let's say we have an example like r equals 4 sine theta. In this case, I want to get an r squared so that I can graph the circle. or so that I can at least recognize that it's a circle. So I'm going to multiply both sides by r. So I get r squared equals 4r sine theta. And if you guys recall, r squared is the same thing as x squared plus y squared. And then r sine theta is actually the same thing as y. So we have x squared plus y squared equals 4y. This is a circle, I can tell because it has x squareds and y squareds, and so I'm just going to make this equation equal 0 so that I can get this circle in some good graphing form. So I need to complete the square on the y parts of this. So I'm going to do negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4, so I'm going to add 4 there and add 4 over here. And so the equation that I'm going to be graphing is going to be x squared plus y minus 2 squared equals 4. I think we might have actually done that exact example already. So I'm going to go ahead and graph that. So I have rectangular graph paper in front of me, or polar graph paper in front of me, but I'm going to pretend that I'm graphing this just like I would have on rectangular graph paper. So my center is at 0, positive 2, so I'm just going to go to the right 2 and put a dot. And then from there I have a radius of 2 because the equation equals 4. So I'm going to go left 2 and right 2 and down 2 and up 2. And then I'm going to go ahead and draw a circle from that. So here's my circle. Now there's a little shortcut for problems like that, and here's the shortcut equation. I would put a star next to it or something. If you have an equation that says r equals plus or minus 2a cos theta, then you're going to have a circle, and the center of the circle is going to be positive or negative a, depending on what the value was there. And then the radius is going to be a. If you have an equation to begin with, like r equals plus or minus 2a times sine theta, that's like the example we just had, then the center is going to be 0, positive or negative a, and the radius is just going to be plain old a. So since that's a formula we have now, we don't have to do the same process over and over to get these in graphing form. We can just graph them. For example, let's say we have the equation r equals 6 sine theta. In this case, your a value is going to be a positive 3, and so I would recognize this is going to be a circle. The circle is going to have a center of 0, positive 3, and it's going to have a radius of 3. So now that I've used the shortcut to say that information, I can go ahead and just write the equation of the circle. X squared plus y minus 3 squared equals 9. And then I could go ahead and graph it the same way that I graphed the other one. All right, we also want to do a little bit of converting from rectangular form to polar form. So for example, in rectangular form, they might say something like x squared plus y squared equals x. And we want to turn this into polar form, so I want to only have r's and thetas in the problem. So I know that x squared plus y squared equals r squared, and I know that x is the same as r cos theta. And I would go ahead and say that could be my final answer. In polar form, y is the dependent variable, so or y is the dependent variable in rectangular form, and that's kind of the equivalent of the polar form. R would be the dependent variable. Sorry, that's terrible. It means you plug in theta to get r usually. So if it's easy to get r completely alone in the equation that your answer is going to be, that's generally the best. In this case, we don't want to divide by r. That'd kind of be like taking x squared and dividing it by x to solve, which we never do. We always factor. So in this case, go ahead and just leave that as r squared equals the other side. But let's go ahead and do one more. If we had rectangular form, y equals negative 3, I want to take the y and write it so it has an r in the problem. This would be r equals sine theta. R times sine theta equals negative 3. And then in this case, it'd be pretty easy to get that r completely alone. And so I'm going to say r is negative 3 divided by sine theta. And then that would be a good polar Next, let's say we have a problem like y squared equals 2x. I know that y is r sine theta, and so if that's squared, then it means I'm squaring it. So that would be like r squared and then sine squared theta. And then over here I have 2 times r cos theta, and I'll just leave that as 2r cos theta. And in this case, you can leave the equation written like that, or if you want to make it equal 0, that would be fine. I would take either one of those answers. This short little unit is mostly an introduction unit anyway, so if you guys were to do these in the future in a math class, then your teacher or professor or whoever would tell you exactly what form they want them to be in. All right, and then last one. Let's say we have an equation like 4xy equals 9. For the x, I'm going to replace it with r cos theta. The y is going to get replaced with r sine theta, and it equals 9. And so I'm just going to say this is 4r squared cos theta sine theta equals 9. Or you could subtract the 9 and make it equal 0. Either one of those answers would be fine.